Okay, good afternoon, everyone. Welcome to this exciting event hosted by CREDS. Today we're launching our report entitled The Role of Energy Demand Reduction in Achieving Net Zero in the UK. And this has been a collaboration effort across the whole of the CREDS consortium. I'm Gillian Annable, I'm co-director of CREDS. I lead the mobility theme and I'll be chairing the events this afternoon. The lead author of the report, Professor John Barrett, will introduce the key findings shortly, and then we'll have a panel discussion around these findings. Joining John on our panel will be Katharina Brandmeier, Head of Climate Policy at Green Alliance, Chris Stark, the CEO at the Climate Change Committee, and Rebecca Willis, who is Professor in Practice at the Lancaster Environment Centre. CREDS is the Centre for Research into Energy Demand Solutions, and we're funded by the UK Research and Innovation's Energy Programme. We started in April 2018 and currently have funding to March 2023. Our research focuses on reducing energy demand, improving energy efficiency and understanding demand side flexibility. And we're a consortium of more than 20 universities, around 150 staff from across the UK, and CREDS is led by the University of Oxford. So this launch of the report and the panel discussion will last about an hour, and we will have a question and answer session. We'll have time for more detailed questions in the Ask the Authors session immediately after the launch, between 4 and 5. So in this session, in the first hour, we're asking if you can keep your questions to the less technical questions and save those for the Ask the Authors event in the second hour. We would also like you to put your questions that you have for the panel in the Q&A box, not in the chat box. So keep any technical questions about the webinar itself, any issues you have with the technology whilst the webinar is running, please, for the chat, and put your questions in the Q&A. To let you know, we're recording the webinar, and also one other housekeeping point is that it'd be wonderful if you are on Twitter, and we'll be tweeting during this. So please follow us, and if you are tweeting, you can use, if you can tag us at creds_UK, and also use the hashtag positive low energy futures, which is how we are, what we are calling this report. Okay. I'd now like to hand over to the lead author of the report, Professor John Barrett. John.
Good afternoon, everyone. So as I said, my name's John Barrett, but this report was obviously not done just with myself. It was done with a large team from everyone from CREDS, 17 of us in total, to in essence understand the role of energy demand reduction in achieving net zero in the UK. Our efforts to phase out fossil fuels are not keeping pace with our emission targets. While we have a target to reduce emissions to net zero by 2050, the level of our emissions in 2050 is not as important as the total emissions released along the way. At current global rates of emissions, we will exceed the global carbon budget to limit global temperatures to 1.5 degrees within 10 years. In essence, we have a decade to act. And we have three broad options to do this. We can decarbonize our energy, ensuring that at the lowest level of emissions possible per unit of energy produced. We can deploy nature-based solutions and engineered carbon dioxide removal options to remove CO2 from the atmosphere. Thirdly, we can reduce our demand for energy. It is the level of our energy demand that determines the size of the energy system and our reliance on unproven carbon dioxide removal technologies. Therefore, we asked, how low can we take our energy demand without impacting on our quality of life? And how do we do this? We've developed a comprehensive framework to estimate the UK's future energy demand, bringing together sector-level energy demand modelling with whole system modelling approaches to determine the role of energy demand reduction. This allows for assessment of energy demand reduction, its contribution to net zero emissions in the short and the long term. These changes are developed in step with the corresponding supply side system and its necessary technology change. We go beyond energy efficiency options and consider energy demand reduction in terms of solutions to avoid, shift and improve the use of our energy. This recognises the need for a stronger focus on social technical dimensions of transitions. Our study provides simultaneous and consistent whole economy and sector level perspectives. This captures the details required at the sector level and reflects the diverse strategies that are applied across all these different sectors. The whole system perspective is also crucial to capture the linkages and trade-offs between sectors, helping ensure consistency based on our chosen scenario narratives. And this has given us 4 scenarios. We could ignore, steer, significantly shift, or completely transform our approach to energy demand. Our ignore scenario shows our current pathway based on known and existing policies and is in line with the implemented policies within the Climate Change Committee's baseline. Ignore would result in a 5% reduction in energy demand. Steer maintains energy service demands but implements a wide range of energy efficiency measures, reducing demand by 31%. Our shift scenario represents a 41% reduction in energy demand and adds broader changes beyond energy efficiency. Our transform scenario more than halves the UK's energy demand and considers transformative changes in technologies, social practices, infrastructure and institutions to deliver energy demand reductions. This involves both energy efficiency and further changes that avoid energy intensive services or delivering the same service differently. Transform delivers numerous benefits such as health, improved local environments, improved work practices, reduced investment needs and lower cumulative emissions. We show that a developed country like the UK can reduce energy demand well below today's global average on a per capita basis while maintaining a high quality of life. This graph shows the energy demand reduction across a number of different sectors. Each sector was modelled independently before being brought together in a whole system model. Reductions are possible across all sectors in the economy. However, they will all involve potentially different options and reductions at different rates. In our transform scenario, all sectors with the exception of industry can be reduced by 50%. The variation exists due to a range of energy efficiency measures available to that specific sector and the ability to maintain quality of life while reducing energy service demands. There will be a different approach for each sector, with more scope for energy efficiency, for example, in domestic building through the implementation of heat pumps and retrofit strategies, while in mobility, larger social changes to reduce the need to travel are considered alongside efficiency options. Let's have a look at how our reduction in energy demand can change the supply side. We are clearly aware that the energy system needs to completely decarbonise while expanding the electricity system to provide for mobility, heat and new industrial processes. The challenge is enormous. It relies strongly on high levels of societal acceptance of new technologies and presumes that the very real technical hurdles of building out new infrastructure in a relatively short period of time can be overcome. This graph focuses on the power sector, showing the 3 of our scenarios. Our transform scenario takes the pressure off the required transformation on the supply side. The scale of investment in expanding the energy supply system is reduced by about 40% by 2050 compared to our steer scenario. This graph shows the demand for power is considerably smaller in that transform scenario. Without energy demand reduction, power generation would represent a 150% increase compared to current levels, compared to a 44% increase in the transform scenario. We in essence show that we can moderate the supply side with a moderate increase, with only a moderate increase in the power sector. So let's see how our scenario affects our efforts to reduce our emissions. This graph shows our projected emissions under the 3 scenarios in 2050. The ignore scenario is not included in this graph, as it is not seen as a valid pathway consistent with the UK's legally binding targets. As a reminder, that scenario describes the effects of existing policies and results in emissions of 390 million tonnes in 2050, and is nowhere near the UK's short-term climate targets or long-term climate ambitions. Our steer scenario that maintains energy service demands also fails to achieve the 2050 target, with 27 million tonnes short, despite a 31% reduction in energy demand and almost complete transformation of the energy system and 50 million tonnes of carbon dioxide removals. These engineered carbon dioxide removal technologies are required in the form of biomass with carbon capture and storage, labelled as electricity generation on this graph. It is only our shift and transform scenario that achieves the target, that at varying different levels implement energy efficiency and broader societal changes that reduce the need for energy services. Our shift scenario still relies on BECCS, the reliance on carbon dioxide removal technologies that have yet to be demonstrated at scale are removed in our transform scenario. We can deliver our emission reduction by only relying on nature-based solutions to address residual emissions. The transform scenario also has the lowest level of residual emissions in the region of 50 million tonnes. This final graph shows our cumulative emissions under our 3 scenarios. Transform CB refers to a tighter carbon budget than the current UK commitment. The UK has consistently tightened its carbon targets over the past 15 years. While there is no doubt that the UK has set an ambitious target, any increase in ambition would allow a more globally equitable distribution of the remaining carbon budget while demonstrating climate leadership. The reality is that emissions need to reduce rapidly as soon as feasibly possible. It is only an immediate focus on energy demand that can offer stronger short-term reductions, allowing us to limit cumulative emissions. In conclusion, without substantial energy demand reduction in the UK, we will not achieve our 2035 target to reduce emissions by 78%. Energy demand reductions are an enabler of cost-effective, timely, and de-risked net zero target. Given the evidence in this report, it is imperative that the UK government outline a detailed strategy and supporting policies to enable energy demand reduction to fulfil its necessary role in achieving rapid emission reductions in the UK. Thank you.